Stephenson 218. Our Sun is often described as a large star, but when compared to some of the other stars in our galaxy, it's actually quite average. Over the past century, astronomers have discovered stars that are hundreds and even thousands of times larger than our Sun. The largest star discovered so far is the star located in the constellation of Scutum. Its name is Stephenson 218, and it might be the largest star we've ever discovered. The giant behemoth is nowhere close to the size of our Sun. It is estimated that if this giant being was in our solar system, its giant size would swallow up planets up till the orbit of Saturn. Its mass is estimated to be 20 to 50 solar masses, which is very peculiar for the size of this giant star. Its luminosity is 44,000 times brighter than our Sun, and it's pretty obvious for a large star this big. The star Stephenson 218 is an M-type star, more specifically an M6Ia type star, which means it's a red hypergiant star. A star's type is determined according to the Morgan-Keenan classification system, where they depict the star's spectral type and luminosity class. Like for example our Sun, which is classified as a G2V type star. The G2 represents its spectral type, which tells us about the star's surface, temperature, and color, while the V represents its luminosity class, meaning it's a main sequence star. In contrast, Stephenson 218 is classified as an M6Ia. The M6 tells us that this star has a relatively cool surface temperature compared to hotter stars, causing it to appear red, while the Ia indicates that it's an extremely luminous supergiant. Despite its cooler surface, Stephenson 218 shines with an incredible amount of energy because of its enormous size. But how did a star this massive become so enormous? Stephenson 218 is believed to have started its life as a much hotter and more massive star. Over millions of years, it exhausted the hydrogen fuel in its core and expanded dramatically, transforming into a red supergiant. Its outer layers stretched across billions of kilometers, creating one of the largest stellar bodies known to humanity. However, its incredible size comes with a cost. Stars like Stephenson 218 cannot remain stable forever. Massive stars burn through their fuel much faster than smaller stars like our Sun, meaning their lifetimes are only a fraction of the Sun's. While the Sun will live for around 10 billion years, a star like Stephenson 218 may only exist for a few million years. In the distant future, this giant star will eventually reach the end of its life and expect to undergo a spectacular supernova explosion, leaving behind either a neutron star or a possibly black hole. For now, Stephenson 218 remains one of the most remarkable examples of just how diverse and immense stars in our universe can be.